Okay, children, here we are going to discuss the answers which are regarding to challenging paper 1. You know that I have started giving you that challenging paper from last week to improve your math knowledge along with the foundation course, along with A-level combined maths. By the way, so it is about challenging paper 1. So in challenging paper 1, the first question, I'm giving you 5 questions which are limited to do within 10 minutes. So you have to quickly respond. So with that, you are practicing both the accuracy and speed, obviously, right? Question number 1. Which of the following statement is or statements are true for all real values, positive, negative and 0 of the number A? Explain your answer or answers. The thing is this. For now, simply, what are real numbers or real values? Real numbers or real values are the numbers which can be represented in a number line. Simply for now. Later we will discuss about real numbers, imaginary numbers and the complex numbers with the progression, right? So just, for the time being, the simple explanation for real numbers or real values are the numbers or the values where you can represent in a number line. Obviously, that is why I have explained there all real values. 0, the neutral value, positive or negative. For all the values, you have to choose the true statement or the true statements. The first, 7a is greater than 3a. For positive ways, this is true. But for 0, once a is 0, 7 into 0 is greater than 3 into 0. You know that 0 into anything is 0. That is not true. Not the answer. The second, 7 into a plus 1 is greater than 3 into a plus 1. So let us say you are substituting values for a. By the way, when you consider about a plus 1, what if a plus 1 becomes to 0 where a is minus? And not only that, for the first question, for the first answer as well, once a is negative, 7a is not greater than 3. For the third answer as well, so I am discussing about the third answer in the first row. There you have 7 into a plus 1 is greater than 3 into a plus 1. That is not true as well. That is true where a is greater than like minus 1. Once it is minus 1 and below to minus 1, that is not true. Now the second answer, 7a squared is greater than 3a squared, the same thing. For the positive and negative values, that is okay since a squares give you the positive answers. But what if a becomes 0? 7 into 0 is never greater than 3 into 0, where 0 is 0 only, 0 is not greater than 0. Fourth answer I am talking about, 5 minus 7a greater than 5 minus 3a. Once you have such values in the two sides of an inequality, we will further discuss about the inequalities to the depth in inequalities lesson. This is just for now. By using your O-level inequalities knowledge, obviously you can solve these, right? So 5 to 5 you can cancel out as they are the same values at the two sides of the inequality. Then minus 7a is greater than minus 3a. Yeah, that is true for some of the a's but not for all the a's. You have to consider the positive ways, negative ways and the neutral a. Once it gets to 0. So 1, 2, 3, 4, all are not true. Now hopefully we are going to check answer number 5, sorry. There you have 217 plus a is greater than 3 plus a, obvious, because you can right away cancel out a despite plus, minus or 0. So 270 is obviously greater than 3 despite of a, regardless of the value of a. So the answer is 5. Clear? Question number 2. How many positive integers less than 2015 can be written as a product of two consecutive positive integers? Explain your answers. Right. Product of two consecutive integers. So what is the first product you can make out of two consecutive positive integers? 1 into 2. 2. 2 into 3, the second one. 2 into 3. It is 6. 3 into 4, the third one. 3 into 4, the third one is 12. Likewise, you can form those numbers as a couple of product of two consecutive numbers. By the way, you can observe a pattern as well there. 1 into 2 is the first couple, which gives you the product of two consecutive positive integers. 1 into 2 is the first, 2 into 3 is the second, 3 into 4 is the third, 4 into 5 is the fourth. Likewise, that is always the first integer out of those two consecutive integers. So obviously with that pattern, 10 into 11 is the 10th product, 20 into 21 is 20th product out of the two consecutive positive integers. By the way, you know that the numbers you have here is 21, 22, 21 into even. So let us say the 20th couple as the products to. So 20th couple is 20 into 21. It will give you like 420, 20 into 21. So that is not the answer. You have to go further. So let us try 44. What about 44? 44 into 45. That is 44 into 45. How much is 44 into 45? I am also calculating here. 44 into 45. 180. 180. 1980. It is 1980. 44 into 45. By the way, since you have the other answer as 45, it is better to check 45 into 46 as well. 45 into 46. 45 into 46 is 230. 184. 2070. So it exceeds 2015. So as you are asked, how many positive integers less than 2015 is sorry, there it is going to be 44 as product of two positive integers. How many positive integers? So you have 44. One is 1 into 2, the second one is 2 into 3, the third one is 3 into 4. Likewise, the 44th one is 44 into 45, which is 1980. 1980. So it is that below 2015 number. So altogether the numbers are 45, the third answer. Question number 3, there you have been recommended that a and a plus 1 over a are positive integers. Means that starting from 1, 2, 3, 4, likewise. They ask, I have asked you, how many possible values are there for a to have to satisfy these conditions. What are the conditions? A and a plus 1 over a both are positive integers. To be a positive integer, you cannot have negative, you cannot have 0, and to be integer, you cannot have any decimals, so there cannot be any fraction. Means simply, what is a? A is positive integer. You can have like more possibilities for a, but by looking at a plus 1 over a, that is also a positive integer. A is again okay for a plus 1 over a, but for 1 over a plus 1 over a to be a positive integer, a is okay. 1 over a should be a positive integer. So once you as far as a is also a positive integer, start from 1. 1 over 1 is okay, 1, but more than 1 for all the positive integers, 1 over a is a fraction. So a plus 1 over a won't be any integer. It will be a fraction, mixed fraction, no complex fraction. So there is only one possible value for a, which is 1. So the positive integers can be existing are 1 and 1 plus 1 over 1, which are 1 and 2. No other values for a can be taken into the count according to the given conditions. Clear? That happens due to that 1 over a. A's are fine for both a and a plus 1 over a, but 1 over a should be an integer to make the things happen for positive integers. Clear? Right. The third we are going to discuss. 3 by 5 of grade 6A and 3 by 4 of grade 6B are girls. If both classes have the same number of girls, which of the following could be the number of students in grade 6A? In grade 6A, by the way, you don't know about anything here. Just it is about a relationship now. So I'm like, I don't know about anything. In maths, when you don't know about anything, from O-level maths, what you do, you give some unknown like X, Y, A, B, those letters are usually used. So this is what you have to do. So let the girls in grade 6A be, let all the children in 6A be simple A, and let all the children in 6B be simple B. Then you can simply make this relationship 3 by 5 of 6A children, which is A, equals 3 by 4 of 6B children, which is B. Alright? So you are asked here, if both classes have the same number of girls, which of the following could be? So that is why both classes have the same number of girls. So 3 by 5 of A equals 3 by 4 of B there. Clear? You have to listen to me. I don't show any simplifications. I'm checking your listening skills. You have to listen to me and listen well and correct your answers, right? Here they have recommended the possibilities of grade 6A children, which is simple A. So isn't it better to make simple be the subject? This is why. So I'm going to make simple be the subject. They are 4 upon 5A. Because by putting these appropriate values for simple A, I have to make sure that B will have a complete number as well, because number of children cannot be a decimal, negative number or 0 here. Clear? So I made B the subject eventually. B is 4 by 5A. So A should be a multiple of 5 to cancel out with the 5 at the bottom. So obviously number of children of class A, 6A, should be 40 for sure. Question, the answer for the question is part 1, the answer number 1. Because B is 4 by 5A, B to have a complete number, A should be a multiple of 5 to cancel out that bottom 5. That is obviously answer number 1. Is that clear? Right. For the final question, find the value and explain your answer further. 0 upon 1. 0 is a number. It means that you have nothing. Nothing here. Neither plus nor the minus. Nothing. Nothing divided by 1. Nothing divided by any plus number or minus number. 0 is that null value, which is the neutral value. It doesn't have any sign. So 0 upon any plus number or any minus number still is 0. Nothing divided by any plus number or minus number still is nothing. Then you are asked about 1 over 0. It is about this. So here you have 1. So let us say you have to get this particular 1. So this is a pen, 1 pen, divided into parts where one particular part is almost negligible in size. So let us say 1 upon 0 means that 1 upon 2. What does mean by 1 upon 2? You have to get this pen divided into 2 parts. 1 upon 3, get this pen divided into 3 parts. 1 upon 0 means that you have to get this particular pen divided into number of parts where such one part is almost negligible. I'll again explain. 1 upon 2. So you can separate this into 2 parts, and one part will be 1 upon 2. So once you need to get this divided by 3, 1 upon 3, one part will be 1 upon 3, one third of the pen. Once you need to get this divided into 0 means that nothing. You need to get this divided into 0 means that you have to get this divided into certain number of parts where such one part is almost nothing. So for how many parts you can get this divided? Where one part even you can't see, it is like almost nothing. It is, you cannot count. In separation, you have to separate this pen in a way that you cannot count those number of parts. There one part will be almost nothing. So that is why the answer is obviously the infinity. You don't say equals to infinity at all, because infinity is not a number. That is just a notation to say that amount is uncountable. Clear? So 1 over 0 is infinite. It tends to infinity. It is not equal to infinity at all. Clear? And by the way, 0 upon 0 is Yes, 0 to 0 cancelled out. 1 upon 1 is not, the answer is not 1. 0 upon 0 is not defined at all in mathematics. So you just need to mention there 0 upon 0 is not defined at all. So we don't have any meaning mathematically for there. So as per that division, I explained you that 1 divided by 2, it is the halves. 1 divided by 3, 1 by 3 parts into 3. Likewise 1 divided into 0, 1 you need to divide that particular one into the parts where one part is almost negligible. So 0 divided by 0, nothing divided by nothing doesn't mean anything in maths. That is the case. So for question number 3, it is not defined in mathematics. No answer you have. Again, for question number 1, it is 0. Question number 2 tends to infinity, or arrow with infinity notation. You cannot make it equal to infinity. Third, not defined in mathematics. Got it? So in the next class, you will be given challenging paper 2. So I hope you will be taking the challenge weekly with more guts to score more marks. Good luck on the next.